Well, good morning, class. This is the beginning of chapter 5, which is dealing with polynomial functions. And we start off with monomials, something that you've seen many times before. But I want to make sure that we remember and please make sure that you're looking at the notes. I don't think you have the notes key, the answer key. I don't think you have a copy of that in paper, but you do have it either on your flash drive or on the Google Class right here. So you can see a lot of good examples of this. But on this first page of notes, page 1, you can see all the different rules. And I just want to make sure that we remember the fact that when you're multiplying, pretty color, when you're multiplying two bases, and the bases are the thing that's being raised to the exponent. When you're multiplying two bases and the bases are the same but the exponents are different, you can figure that out, the answer, simply by adding those together. When you have a power raised to an exponent, then you can multiply those exponents together. The quotient rule is the same idea as the multiplication. We're just subtracting them. And it comes down to just the basic ideas that if you have a certain number of A's multiplied by another certain number of A's, how many A's do you have? Well, however many you have, just by adding them together. And right here, where are there more A's? On top? Well, if so, then you subtract those to get your answer. What if you have a negative exponent? Negative exponent deals with placement. If you have a to the negative n, that is the same as 1 over a to the positive n. You place it in a different location, which again we could explore different ideas for this, and I think we'll talk more about this when we get to the exponential and logarithm chapter. And then finally, anything raised to the 0 is going to be 1. The exception to that is 0 itself. 0 to the 0, let's not talk about in this class. But a to the 0 is going to be 1. So that is your idea of those basic exponent rules. Again, look at the example answer key, and it will give you some good ideas. There's the bell, but hold on, I'm almost done. Polynomial. A polynomial function that is just a collection of monomials. A monomial is a bunch of things multiplied together. A polynomial is a bunch of those monomials added together. And standard form can look a little bit intimidating. Don't let it intimidate you. But where we have our idea of well, I don't know if we'll have an example of this quite yet. But standard form is exponents in descending order. Right? So keep that in mind. So when you look through this right here, what is the highest exponent of the k that you see? You see the negative, the opposite of k to the 5th. And then you look, there isn't a 4, that's okay, but we do see here's a 3, so 3k cubed, and so forth and so on. If we have multiple different variables, usually go with the first variable you see in the alphabet and follow its descending order down. But things get a little bit subjective in whatever you think for those. Okay, classifying. I'm going to let you look at the vocab, again, the answer key to see what these things are called. I don't find it a good use of our time together on the video. You can see all those different names and classifying them well. You can either classify by degree or you can classify by number of terms. They are not the same. And then finally we have either adding and subtracting, that's easy. Multiplying, that's foiling. What if you have like this kind of FOIL? Well, to realize what a FOIL is, what we're doing is we are distributing the W to each of these, and then we are distributing the -7 to each of these. And watch how I do this. The w times the w squared is w cubed. The w times the 2w is plus 2w squared. The w times the 1 is w. And now when I do this underneath, I'm going to line them up so they combine like terms. A negative 7 times a w squared is a negative 7w squared. See how it's right in line with the other squared? Negative 7 times 2w is minus 14w, and a minus 7 times 1 is minus 7. And now these add together nicely as w cubed minus 5w squared minus 13w minus 7. And that is our final answer. So what if you have something cubed? Just take two of them. So number 9 here, 2c plus 5d times 2c plus 5d times 2c plus 5d. Foil two of them together. So I will ignore this for now, do this, get my answer, and then multiply this times that new answer, kind of like I did right there. So follow the examples that you see and see what you get. Lastly, a bunch of Valentine hearts here for dividing. We'll get to later on what happens if it doesn't divide nicely. We'll see, but for right now, just split this up into two things and reduce each of them. Split this up into three things, reduce each of them. Well, what if you have something like this right here that looks kind of strange? Well, remember this -1 deals with placement. So this is the same as 14 a to the 4th b cubed minus 20a squared b squared plus 2ab, all divided by the 2ab. Now it looks like all the other ones. Again, you can split that up into the three different parts, reduce each of them, and you'll have your answer. All right, that's it for section 1. Should be a pretty great, easy section for you. I'll see you at section 2.